This is my 1982 Corvette with the Crossfire fuel injection. So for this video, I wanted to show off a program called WinALDL. So these early pre-OBD2 cars, they don't throw a lot of check engine lights very often, but you can do some real-time scanning to see the long-term fuel trims, and you can get a pretty good idea objectively how these cars run. This is really helpful because you can log it and make baseline readings, and then anytime you make any changes, wrench on the car, you can see whether you're making an improvement, or you can even pinpoint kind of what your most likely suspects are. So let's go take a look. So this is the diagnostic port in the 82 Corvette. It's underneath the ashtray here if you pull that out. So that's the assembly line diagnostic port. I think they introduced it like in a experimental 79 Cadillac, and then the 80 California Corvette with the 305 had a computer carb. Then I guess it became standard but pretty lame in the 81. And then the 82, you still only got an A and B pin that give you data at like a really abysmally slow 160 baud. So it's a voltage high on I think pin A, and then pin B is like ground. This picture, I would go look it up. I think it's upside down. I think pins A and B are in the lower left. Don't quote me, I would go look it up. But those are the pins you would normally use to put the paperclip in to get the check engine light to come up. So you can get a 12-pin cable that has a built-in USB to serial converter for newer computers for about $60. Works in Windows 98 through 10, I think, pretty much out of the box. And then if you're really old school, you have an old serial like printer port laptop, you can use just a serial to serial one. They're probably a little cheaper. But get the 12-pin and realize you're only going to be reading on pins A and B. And also these have jumper pins on them on the body of the cable that allow you to select the resistance. And the 82 I don't think needs a resistor, but like some of the later OBD1 cars, later Corvettes, they actually can put into limp mode if you have the wrong resistor on there. So be mindful of that. Alright, so this is the WinALDL interface and all the windows you have available. So you have the main window here, which is this big one. I have it opened up to the, I think the O2 tab right now. That's the oxygen sensor. There's also the integrator and the BLM tab. And then you also got an error codes tab that tells you any check engine light codes, so you don't have to flash the paperclip thing. Sensor data gives you the raw data stream, so you can see things like coolant temperature sensor, other interesting things as they happen. The flag data has radio boxes that check or uncheck depending on what's coming in. Like you can see if it's in closed loop, see if the IAC, the idle air controllers are stepping or what they're doing. Pretty useful. Also on this window, you have the buttons at the top that says like configuration, data logger, and dash. If you hit the dash button, you'll get this little dash display that pops up that gives you your speed, RPM, manifold absolute pressure, throttle position sensor, and O2 sensor. Then the other button you have is configuration. So that's going to bring up the configuration window, and you're going to choose your ECM type. And for the 82 Corvette, I think it's just three options here. It's the 122.5550, comma, blah, blah. So pick that one, and it'll give you the right fields and conversions for the data stream. Your TPS voltage, if you want to manually set it, I think the shop manual has like a slightly different value than 0.54 volts. Anyway, so that window's helpful. You've also got the data logger button that you can create logs with. So the important setup step you're going to may or may not need is changing your COM port. So whatever cable you've got plugged in, to your car, it's going to come up in the Windows Device Manager, and it'll tell you what port it is. Like in this example, it says USB serial port COM3, so that it's assigning COM port 3 to that adapter. So you're going to go into WinALDL and then the configuration and change from the COM port 1 to COM port 3, close and reopen, and then you shouldn't get any error messages. And if your car is ignition on but not running, you should start seeing data start pulsing into the WinALDL, which is pretty cool. So as far as how to create these log files so you can save them for posterity, you go to the log data and you check your radio boxes. At least check the sensor data and the flag data, so that way you get something that you can check all of them, and then hit start whenever you want to save this stuff. And these files are going to be text files that in the old versions of WinALDL, they would put them in the C program files WinALDL with like the date code stamped on the file name. I think in the new version, like for Windows 10, it puts it in My Documents. So the nice thing that you can do to make it more readable, because these text documents, are kind of a jumbled mess that, nothing lines up, you just hit Control A, select all, copy, and then paste them into a empty spreadsheet, and then it lines it up by rows. And you can do some fancy math like averages. You can hit min and max type thing. The only thing I'll say is the fields tend to jump lanes because the computer on the car is so slow that like the 160 baud, it can't quite do it. So sometimes it'll drop to like 159 baud, and then it'll hiccup, and you'll have a line that's transposed. And you'll see if you look at your logs, and you just either delete that line or copy paste it to the right alignment, so that way your averages are right. So now to get into kind of the meat of it. So the table that's really useful for me for getting an objective measure of how well my car is running is the block wear multiplier. So that is going to be your long-term fuel trim. So if you go to the BLM tab, like I have this one up right now, this is my car, when it had some issues. So anyway, these values should be hovering around 128. They should be, within plus or minus 10%. That's what I've heard is, about factory or acceptable. So that's going to be 115 to 140. So when your values are falling outside that, you're going to have drivability issues. So the reason it's 128 is because it's half of 256 bits. So if it's greater than 128, then you're going to have a lean condition, and then if you're below 128, then that means you're going to have a rich condition, or at least that's what the computer in the car is perceiving of the situation, is trying to adjust. So like in this example, I've got values like 108, 138, 113. These are not great values to be seeing. So in my case, this was because I had a vacuum leak at the PCV valve and the busted AIR. I had a diverter solenoid that was just like not having continuity, wasn't actuating. So it was just letting full manifold vacuum, divert the AIR cold air back into the air cleaner while I was just, idling and driving, slowly, which is not good for the air-fuel ratio. And so my car was kind of freaking out, and I had, really lousy gas mileage, like I think 11 miles per gallon, which is not normal. So this is a more recent log of my car. You're going to want to see your block wear multiplier values hanging out around 128. Here, if you look at this table, these are all within 8%. So in my case, I went up to like 18 miles per gallon. Granted, I don't have the original 700 R4. Somebody, took out my car and put a turbo hydromatic 350 without overdrive in there, but I'm still getting 18 miles per gallon. The car is much better. I got the car with 10-year-old tires, and I didn't think there was anything wrong, but as soon as I made all these tune-ups and fixes, the thing was like a spider on roller skates. It was just, all over the place. I even have brand new, soft, decent tires on there, and I'll still break I'll break it loose if I don't drive with my big toe. It's just a dramatic improvement. I don't want to get too far into it here, but the general equation for the base pulse width, which is the length of time that the injectors stay open per pulse, is a bunch of coefficients here, plus a couple of values that you can sneak a peek at. It'll help you understand how your car is running, or how your computer's DCM perceives the situation to be. So you've got your manifold absolute pressure, your MAP values, and that's going to be like your inverse of your vacuum. So if that's, doing the funky chicken and all over the place in ways that don't make sense for the RPM and throttle, then maybe you've got a bad sensor or a vacuum leak. You can see how that really impacts the base pulse width pretty badly if that's off. Then the volumetric efficiency is like the factory tune coefficients. So that's a table that's hard-coded. You can't change it on these little VCMs. So in order to compensate for, changes in the engine, like wear and tear and, temperature, altitude, octane rating. You've got these things called the block learn multiplier and the integrator. So these are your long and short-term fuel trims. So the integrator swings around, a lot more violently from off of 128, and that's just kind of a natural part of the way the catalytic converter works, because the catalytic converter wants to be at 14.7 to 1 air-fuel ratio, but it likes to oscillate a little rich, a little lean, because different chemical reactions occur in rich and lean states. So it's got to kind of shuffle back and forth and clear all the reactants out. So anyway, the block learn multiplier kind of follows the integrator. It's kind of like a running average of the integrator in a way. So the block learn multiplier values, if your computer is thinking that it's consistently kind of lean, then it's going to have a higher value than 128. So if you think about it in the math here, if you've got a bigger number, then the base pulse width is going to get larger, so the amount of time that the injector is spraying and holding open is going to be a little bit longer. And then conversely, if your car thinks it's running way too rich and it wants to back off a little bit, then it's going to keep changing the integrators, and then consequently over time the BLM is going to start dropping to below 128. So I hope this video was helpful for everybody watching. Again, this software is free. The cables aren't free, but this is definitely something to keep in your toolkit. Good luck, everybody.